Now, before we start, I want you to think about how can you implement this script. Pause the video, give it a couple of minutes, and then resume the video and check how did we implement it. So we have this number that we want to convert to words. The first step is to obtain each part. For example, we'll obtain the millions part by integer division this number by 1 million. This will result in 532. Then, to obtain the thousand part, we will modular the number by million and then integer division by 1,000. Then, to obtain the hundreds part, we will modular by 1 million and modular by 1,000. Now that we have obtained the millions, thousand, and hundreds part, then we can obtain the hundreds part for each number by integer division 100, the tens part by modular 100, and then the units part by modular 100 and modular 10. We have transformed this number into 3-digit number of each part, and then we obtained a single number for each part of these. We have a dictionary that its keys are the individual numbers. For example, 1 will equal 1, 2 will equal word 2, 3 will equal the word 3. So let's experiment a little with the command line. I'll define variable n will equal to 987,654,321. If I integer division n by a million, it will return 987, which is the millions part. But if I modular with a million, then integer division by 1,000, it will obtain 654, which is the thousand part. But if I modular n by a million and then modular n by 1,000, it will return 321, which is the hundreds part. Okay. Then, for every part of it, let's, for example, take the 321. If I integer division it by 100, it will return 300. If I modulate by 100 and then modulate by 10, it will return the units. And if I modulate by 100, it will return 21, which is the tens part. And if I subtracted this from this, it will return 20, which is the tens part. So we will convert each part, the millions part, thousand part, hundreds part, to a 3-digit number. And then each 3-digit number, we will obtain the hundreds, the tens, and the units. And then we will define a dictionary, for example, called num, which will have key 1 equal word 1, 2 equal 2, 3 equal 3. If I wanted to retrieve the word equivalent to integer 1, I'll just type num of 1. For 2, it will be 2. For 3, it will be 3. Okay. So let's begin building our script. First thing, we will define numbers dictionary, which will have 0 index for nothing, because we will not convert 0 into the word 0. 1, 1, 4, 1, 2, 4, 2, and etc. I'll pause the video, type in the complete dictionary, and get you back. Okay. I have typed the remaining entries in the dictionary. It contains a number from 0 to 10, then 11 to 20, then 30, 40, 50, 60, 70, 80, 90, 100, then 1000, and then million. Okay. So now if we extract it from each number, the next step is to extract the component of each number. So let's work with a number. I'll define a variable called num. For example, it will have the values 3, 4, 5, 5, 6, 4, 3, 2, 1. Okay. So this is 354,564,321. We will experiment with this number, and then we will, after we verify that the script is working correctly with our test number, we will ask the user to input his number. Okay. First thing, we will have to extract the million parts, 1000 parts, and hundreds parts. So let's say that mil will equal to num integer division million. Okay. So this will return the millions part. 1000 part will be the same thing. Let's give this also millions or mil part for short, and this vowels, which will equal to num modular 1 million, and then integer division 1000. Okay. And then the hundreds part will equal to num again, and then modular 1 million modular 1000. Okay. So let's try this out. I'll select this part. If you press Alt-Shift-E, PyCharm will execute the selected part in the Python console. Again, if you have selected part of your code and want to check how it will work in Python, okay, if you selected part of the code and clicked on Alt, Shift, and E, that is Alt plus Shift plus E. Okay, this will execute this part in the Python console. So the million part is correct. We can see here the variables. Million part is 345. The 1000 part is 564, and the it should be 100. This is an N, not M, is 321. Very good. Okay, so we have extracted 3 numbers of each segment. If the number doesn't have 3 full numbers, for example, it's 1 million, we will deal with that later. Okay, so how to convert this to hundreds and units? Same strategy. So let's say that we will work on the millions part, for example. So the mil part in here is 354. If we integer divided this by 100, it will give us 3, which will be the 100th digit. And if we modular this with 100, it will give us 54. And we need the last 2 digits because, as you can see in here, we have 10, 11 until 90. These are 2 digits. So if the number is 60, for example, we should have it as 60 or so. So we will need the 100 part, and we will need the tens part, and we will need the units part. The tens part will be 50. To get this, we will use modular 10. This will give us the last number. If we subtracted this from this, it will give us the tens part. So since we will repeat this operation multiple times, so we will create a function to do this. So to create a function, normally when you create a function, you put it at the top of the script. This is for convenience, it doesn't have to be. So let's put it in there. I'll define function called get parts, for example, and it will take num. Okay. First, we will have to check if the number contains 3 digits or less. Okay. How we can check the length of an integer like 564? We can simply convert it to a string and check its length. So to check if the numbers have a 3 digit, we will check if len of string of num, we have converted it to string, and then we are returning the length of it. If it's larger than 2, this means that the num is 3 digits. We will proceed with our strategy. So hundreds part will equal to num, integer division 100, tens part will equal to num modular 100. Okay, and in here we need to check for something. If the number is less than 20, it will be treated differently, because if it's less than 20, it will be directly one of those, since we have the numbers from 20 to 1. Okay, so if it's less than 20, it will be directly one of those. So if tens less than 20, then units will be equal to tens. Okay, and tens will equal to 0. Just bear with me. Else units will equal to num modulo 100 modulo 10, same as this one. Okay, and the tens will equal to num modulo 100 minus units. Okay, great. So let's check this out. And we will keep in mind that we will call this function with an integer that contains 3 digits. So I'll select it and execute it. And then let's call get parts of 3, 4, 5. It will not return anything because we did not return anything. Okay, so we will have to return 100, tens, and units. Okay. Now let's do this again. Okay, and then let's call it with get parts of 1, 2, 3. Okay, this is very nice. Okay, let's call it with 1, 1, 1. Very good. So because the tens is higher than 20, it returned to 20 in here and 3 in here. And if it's less than 20, it will put 0 in the tens part and it will return 11 by itself. Very good. So let's complete the function. What if this part have less than 3 digits? Very simple. This means that it will have 2 digits or even 1. So we will check if num less than 20. We will do the same thing. This means that 100 will equal to 0. Tens will equal to num. If it's less than 20, then tens will equal to 0, and then units will equal to num. This is the same as the above one, excluding the 100th part. Else, if it's greater than 20, then again 100 will equal to 0. Tens will equal to num, and then we will an integer division, and then units will equal to num 10. Okay, let's remove the extra spaces, and since Han is equal to 0 in both cases. We will put it in here and remove it from both sections since it's redundant code. Okay, now let's try the function again. I'll select it and press Alt-Shift-E, and then let's call it with get parts of 23, for example. This will return 23. Let's give it with 13. This will turn 13, 113, 123. Very good. So our functions are now working correctly. We just need to call the function with each part of those. So let's call the function in the million part, get parts of mil. This will return 354. Very nice. Let's call it with the 1000 part. This will return 564. This is very nice. And let's call it with the hundreds part. Sorry, we haven't ran this section again, so it's still, the variable name is still HUM. We will run it again now. So this is very nice. So we have now extracted each part. Okay, so we can execute this function on each of those parts and it will get this part individual numbers. Okay, let's execute this again. So the variable name is correct. Okay, so now I'll say that han, comma, 10, comma, units will equal to get parts of mil part. Okay, then if we executed this, the 100 will be 3, tens will be 50, units will be 4. Okay, so we'll define here a variable called text will equal to an empty string. We can say that text plus equal. We have said that plus equal is a shorthand for text equal text plus something. Okay, now we have the 100 part. We can simply use numbers of han, for example, which will return 3. This is correct. And of tens, 50. And of units, which will return 4. So the million part was 354. So this is correct, but the 100 should have some text appended. So if the 100 is not empty, by the way, we don't need to type 0. If han print han, this will means if 100 have a value, 100 have a numbers, text will be numbers of han plus space plus numbers of 100. So this will specifically print the word 100. So numbers of han will return 3 and then space done 100. We will try it right now on the command line. I'll add here a space. Let's pick this part and execute it in the command line. Copy this part and execute it in the Python console. This will return 300. Okay. Then we will check for the tens. If the tens are 0, tens text plus equal, this means that it will concatenate from the previous one. Text equal plus numbers of tens and the space at the end. If units, then text plus equals numbers of units. Then we'll add a space. Okay, this is the first part, which means that let's run it out. Text will have 344. Let's review our mail part. Text will have 354, which is our millions part. This is correct. We can repeat this 3 times for the 1000 and the hundreds. After this, I'll have if mel part. I'll append the text plus equal millions and then come. Okay. Now we will repeat the same thing for the 1000. Actually, we will copy all of this and then I'll paste it in here, but we will work on the 1000 part and it will be the same, except that this will be 1000 and then we will do the same. Then we will do the same for the hundreds part. Okay. So finally we will print text in here. So let's check it out. Okay. 354 million. This is correct. 564,000. 564,000. This is correct. 321. Wow. Cool. Okay. But I don't like this redundancy at all. We have repeated so many code. So let's do something else. I'll just put a comment in here and I'll type num equals to input. Please enter a number. And we will not forget to convert this to an integer since input returns a string. Let's right click and run convert. I'll enter 999,999,999. This will return 999,999,999. Very cool. Let's try another number. I'll try 123, 123, 321. This will be 123,123,321. Very nice. Congratulations. Okay, but as I said, I don't like the redundancy in here. So we can we can do something a bit clever. Okay, before we do anything else, I'll show you a nice trick. I'll right click in here and create a new file and create convert to. I'll just copy everything and paste it here. Now, if we have breaked anything, at least we have our version still working without any problems. Okay, so let's do a very nice thing. Now we have the millions part, hundreds part, and thousands parts. I'll declare parts list, which will contain mil parts, thousands parts, and hundreds parts. Then for part in parts, so each part will have 3 digits, as you can remember. So if part, which means that if it have values, it's not empty. For example, if the millions part is empty, if part, then 100 and tens and units will get parts of part. So these are variables now. I have 100, tens, units for any one of those 3 parts. Okay. Then let's first take the text and move it before this loop. Then we can remove this and we can put this if statement directly after this one. But how to check if I am the millions or thousands or hundred? Because I want to add this. Okay. And now I don't have mil part. I am inside the loop. So these are the parts I have: millions part, thousand parts, and hundred parts. So we can do something else. If parts dot index of part equals 0, this means that I am in the millions part, right? So I'll append this. And then I'll copy the same statement because we will do the same thing with the 1000, but instead of 0, it will be, as you guessed, 1. Okay. And this will be 1000. That's it. And we can remove all of this. By the way, to comment all of this in PyCharm, to comment a whole complete section, you can just select the section, click Control and division sign. Okay, this will comment all this section. And I'll take brand text, copy it, and move it up there. So let's right click and run convert. Okay, let's enter number 1, 2, 3, 4, 5. Oh, so it's saying that at line 67 it has an error. So we should have moved this inside the if statement, because if there is no part, which means that the first part, which means that if some part is missing, for example, the million part, it should not execute this command until there is these parts. So I'll move it here and let's try it again. 1, 2, 3, 4, 5. 12,345. Okay, very nice. So let's try this again. 5, 4, 3, 2, 1. This should have been 54,321. Okay, we should check this. So let's put a breakpoint in here and execute the debug. 5, 4, 5, 4, 3, 2, 1. Okay, first part is 0. So we have moved directly to the second part, which is 54. And here 100 equals 0, tens equal 5, units equals, because this is 5, this is not correct. This should have been 50, not 5. Okay, so let's debug this again, but we will step inside the function. 5, 4, 3, 2, 1. Let's step inside. The length is not greater than 2. 100 will equal 0. If it's less than 20, no, it's not less than 20. Here is the issue. This should have been multiplied by 10, because this, okay, let's execute this. If we divided the integer division by 10, it will return 5. But if we multiply it by 10 again, it will remove the units part and it will return 50. Okay, so let's stop the execution and execute it again. 5, 4, 3, 2, 1. 54,321. Cool. Let's do it again. 6, 8, 7, 5, 4, 3, 5, 4, 2, 1, 1, 0. This is 687 millions, true. 542,000, correct. 110. Very good. Okay, let's try another number. 1, 2, 3, 4, 5, 6, 7. This is 1,234,567. Okay, this is cool. What you have seen in here is a complete development process. First, you have to think about the problem and find out how you will approach it. Then you will write what they called quick and dirty solution. And after that, you can enhance it a bit more. In the middle or between all of these processes, you will have some errors which you will have to debug, or you will consolidate some code to have much nicer code. Okay, this will conclude our project. Thank you for watching and join me in the next lecture.